Dear students, we are in Theory of Computation lecture series and we do discuss about finite state machines. We have completed deterministic finite automata. Now we are going to do non-deterministic finite automata. We call it as NFA. NDFA or NFA, both are one and the same. Let us have a small discussion about comparison of NFA as well as DFA. So this is DFA and this is NFA. So this is the diagram for NFA and this is the old diagram which is for DFA. Now when we compare DFA and NFA, what is the conclusion here? For Q0, if you give 0, it will go to Q0 only. It won't go anywhere. Deterministic. We are very clear. We are well defined. For Q0, if you give 0, it can go to Q0 also, Q2 also. It is not deterministic. So we call it as non-deterministic. For Q0, if you give 1, it will go to Q1 only. No other choice. Very clear. One next state. Given current state, we have only one next state. Only one next stage for the given alphabet. For Q0, if you give 1, it can go to Q1 also, Q3 also. Multiple next state. Given current state, there could be multiple next state for the single given alphabet. For Q0, if you give 1, there is no choice. You have to go Q1 only. It has no choice. For Q0, if you give 1, you do have a choice. You can go to Q1 also, Q3 also. May have a choice. Let us have a simple definition for NFA. I have taken an example. For Q0, if you give 0, it is Q1. What is L? It is set of all string that ends with 0. If it is ends with 0, starting can be anything. 0 also, 1 also. So the NFA is also made up of 5 component, 5 tuples, similar to DFA. We do have Q, sigma, delta, Q0 and F. What is Q? Set of all states. In this example, Q0 and Q1. What is sigma? That's called alphabet. In this example, 0 and 1. Q0 is nothing but initial state. It is Q0. F is nothing but final state, which is Q1. What is delta transition? For the given state, if you give alphabet 0 or 1, for the given state, if you give alphabet, where it will go? Where it will go? For Q0, if you give 0, it will go to Q0. For Q0, if you give 1, it will go to Q0. Again, for Q0, if you give 0, it will go to Q1 also. For Q0, there is no 1 here, it is already completed. For Q1, if you give 0, sir, 0 itself not there, no problem. Null. A new concept in NFA, null. It is not there in DFA. For Q1, if you give 1, 1 is not there, so result is null. These are all the possible next state. This whole group is called Q. This whole group is called alphabet. This whole group is called result. In DFA, it is Q. In NFA, what is that? 2 states. What are the 2 states? Q0 and Q1. What are the possibilities? You please have a look. Null is there. Q0 is there. Q1 is there. Both Q0 as well as Q1. This blue color stripe is nothing but both Q0 and Q1 is there. Which means, if you take A and B, 2 states, A and B, null is there, A is there, B is there, put together AB is there. Okay, so null, Q0, Q1, put together is 1 state. It may looks like 2 states, sorry. If you put curl bracket, parenthesis, it will be only 1 state put together. So, total there are 4 different results for 2 states. 2 power 2 is 4, 2 power q is 4. If it is 3 states, what happen? A, B, C. Let us take null A, B, C, AB, AC, BC, ABC. Like that, null Q0, Q1, Q2, Q0, Q1, Q0, Q2, Q1, Q2, all three. So total 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, sorry. 1, 2, 3, 4, 5, 6, 7, 8. So total 3 states, 2 power 3 is 8. So how many result possibilities I gave? What is the double braces here? Q0 also, Q1 also. For Q0 if you give 0, Q0. For Q0 if you give 0, Q1. So what is the answer? Q0 or Q1 or both? Both. That's called a new state. So who is here answer? It is just 2 power Q because the gave answer is 2 power Q. We got the new definition. Let us design NFA which accepts strings of zeros and ones, ends with 0, which means ending should be 0, starting can be anything. So minimum requirement is 0. Please have a look. Ending is nothing but 0. So if it is one requirement, I will have 2 states. Already we discussed. Ending is 0. Starting can be anything. So it can be 0 also, 1 also. That's all. Nothing else. Sir, what about 1? Don't bother because it is null. Testing. If I give 1, 0, 0, what happen? 1. Next 0 here also, 0 also. Another 0 also, doubt. So we'll have to redraw the diagram. Q0. If you give 1, it will go to Q0. Doubt not there. There is no doubt. Next term 0 is coming. If I give 0, one possibility is Q0, other possibility is Q1. One possibility is Q0, other possibility is Q1. This 0. One more 0 is there. You have to start from here. Okay, you have to start from here. For Q0, one possibility is Q0, other possibility is Q1. For Q1 also you should go for 0, but it is not there, null. Leave it. We can say dead state or we can remove. Now, if I give 1, 0, 0, if you start from Q0, at any chance, are you ending with a double circle? Yes, obviously. So NFA accepted. NFA is also rejected, but one place it is accepted. This is what the problem we are doing. So in this type of problem, very simple, you have to show the path, nothing else. If there is any path in running a machine that ends in a set of states, it ends in a set of states out of which one state is the final state, then NFA accepts. Now I will just show one more example, example 0, 1. So start from Q0, with the first symbol 0. You can go here also, here also. So for Q0, one option is Q0, other option is Q1. Next to 1, okay, once you reach 1, then only it is called the final state. For Q0, 1 will go to Q0 only. For Q1, 1, nothing is there, which is null. So who are all the final state? Q0 is one final state, null is in one final state. Did you reach a double circle? No. So no accepted state, NFA rejected. Okay. With this, we have discussed a simple introduction about NFA, that is called a non-deterministic finite automata. That is, we are not clear what may be the next state. It can be anything. We'll have how to minimize NFA and how to convert NFA to DFA in the next coming video lectures. Thank you.